Hi everyone, welcome back to my YouTube channel. We're just going to be quickly going over mapping notation and mapping rule today. Um, Mapping notation is used for when we want to figure out the points of a function after the transformations have been applied to it. It's another way of doing this instead of order of operations. Before we start, I just want to go back and look at what are the transformations that are occurring to the function. Remember that transformations of functions are always going to occur to the base function. Today we're going to be looking at the base function of y equals square root x, but it really doesn't matter because the same rules can kind of be applied throughout. So if we look at the functions, we need to remember that when we have our a value represents a vertical stretch or compression. Remember that if a is greater than 1, the absolute value of a is greater than 1, it's going to be vertically stretched by a factor of a. If a falls in between 0 and 1, it's going to be vertically compressed by a factor of a. And in general, if a is negative, it's a reflection of over the x-axis. Just a reminder, when we're looking at the stretches and compressions, we're looking at the absolute value of A. That means that irrespective of whether it's negative or positive, that is going to tell us if it's stretched or compressed. The negative and positive in terms of A really just tells us, is there a reflection in the x-axis or is there not? If A is positive, there's no reflection. If A is negative, there is a reflection. So for example, if you were to have an A value of a negative 1 over 2, the 1 over 2 tells us that it's compressed, and the negative tells us that there is a reflection in the x-axis. The negative and positive part of the a value operate independently of the absolute value. That's what tells us the stretch or the compression. Okay, same idea with k. If k is greater than 1, it's actually the opposite. It's going to be horizontally compressed because when we pull k out of the function, it's going to be 1 over k. Mapping notation actually takes this into consideration, so you don't need to change the value of k when you're putting into the mapping rule, but you need to be careful when you're describing the transformations. You need to take into consideration that you're going to have to flip the k value when you're describing. So if you have a k in between 0 and 1, just remember that it's going to be horizontally stretched by a factor of 1 over k. So for example, if you had a k of 1 over 2, when you write this into mapping notation, you can write it as x divided by 1 over 2, but when you say it, you have to say a horizontal stretch by a factor of 2. Again, same idea. If k is less than 0, right, it's a negative, it's going to have a reflection in the y-axis. When we have C and D, those are our translations that represents, C represents whether the function moves up or down, D represents the horizontal shift, so left to right. If C is greater than 0, we're going to move C units up. If C is less than 0, we are going to move C units down. If D is greater than 0, we're going to move D units to the right. If D is less than 0, we're going to move D units to the left. Just a reminder that when it's inside the function, it's x minus D. So when we pull this out, we need to make sure that we are changing the sign for D to positive if it's a negative, or if it's a positive in there to a negative on the outside. So just remember to change the sign of the D value. Okay, so I think the best way to remember how to do this is to actually just practice it. First things first, anytime you have a function like this, you need to make sure you factor out the k value. So I'm going to just go ahead here. It's not factored for you, so we're going to have to pull out that 1 over 2 value in front of the x. So I'm going to do g of x is equal to negative 3 square root 1 over 2. And when I do this, I need to divide everything inside the bracket by 1 over 2. So 1 over 2 divided by 1 over 2 is just 1. Negative 2.5 divided by 1 over 2 is going to give me negative 5 plus 4. Now I can go ahead and read off what my A, K, D, and C values are because your K value changes when you factor. So my A value is going to be the negative 3 right in the front of this function. My k value is going to be the 1 over 2. My d value is going to be positive 5 because the sign changes, and c is going to be positive 4. We don't change the sign for c, so that's something important to remember. If I wanted to list out my transformations here, I know that because my A is -3, I have a reflection in the x-axis and a vertical stretch by the factor of 3. I know because my K value is 2, I'm going to have a horizontal stretch. Remember, when we have K, we flip it. I'm going to have a horizontal stretch by a factor of 2, right? That's just flipped 2 over 1. Then I have a horizontal translation right by 5 and a vertical translation up by 4. Um, sorry, this should say up by 4. Because my 4 is positive. A few things to remember here. If we're going to look purely at what is happening where, the vertical stretch is going to mean that all of my y's are multiplied by 3. The reflection in x means that all my y's are multiplied by -1. And the vertical translation up means that I'm going to add 4 to my y values. On the flip side, if I look at just my x's, I have a horizontal stretch by a factor of 1 over 2, meaning that I'm going to multiply all my x's by 2, and then my translation right by 5. If I was to write this into mapping notation, I would write it as x divided by k, so x divided by 0.5 plus d, which in this case is plus 5. If I had a, y plus c, it would be a, which is -3, y plus c, which in this case is 4. So the mapping rule or mapping notation is represented by the equation x divided by x plus d, a, y plus c, which makes sense, right? All the x values, you're going to be multiplying them by 1 over k and adding the d value. All the a values, you're going to be multiplying them by the a value and adding the c value. If we look back at how to do this using order of operations, you always go ahead and you multiply the y's by the a value because you're always going to put the structure expressions first. So multiply all the y's by the a value, right? Then you multiply all the x's by 1 over k, which is happening here when you're doing x divided by 0.5. Then you go and you put your translation. So then you take all those new x's that you had, add d. You take all those new y's that you had, add c. What mapping notation is doing is it's literally just doing it in one step. So we're always going to start off with our base function. We know here that our base function is going to be f of x is equal to square root x. I know this because that's my parent function. The square root sign kind of gives it away here, right? So I know that's my parent function. My parent function, I'm going to go back and look at what are the points. So for square root x, we always use the points 0, 0, 1, 1, 4, 2, 9, 3, and 16, and 4. So I actually like to go ahead and plot in my parent function first. So I'm just going to go ahead and put that in. So 0, 0, 1, 1, 4, 2, and 9, 3. And just because I have the space, I'm going to do 16 and 4. This might not be something we use after. We might only be able to use the first 3 points because this graph is stretching both horizontally and vertically, which means that we might just not have the scale to do all of them. But we'll put it in anyway. Okay, so that is what my parent function looks like. Then what I do is I go ahead and I find my mapping diagram or my mapping notation. We already did that, so we did x divided by k, which was x divided by 0.5 plus 5, -3y plus 4. I personally don't like to put bracket or decimals in the denominator. I also know that x divided by 0.5 is the equivalent of 2x, right? If I did that math, it'd be x divided by 1 over 2, right? So I like to write it like x divided by 1 over 2. When we're multiplying fractions, we keep the first, change the sign, and then flip the second fraction, so it becomes 2 over 1. So that's how we get 2x over 1, which is the same thing as saying 2x. So then we have 2x plus 5, -3y plus 4. And now basically what I can do is I can just take all these original points of my function, right, and plug in the x and y values. So I always like to start off with the x's. So I'm going to do 2 times 0 plus 5. So I'm just going to put 0 into this mapping diagram. So 2 times 0 plus 5 is going to give me 5. right? Then I'm going to do 2 times 1 plus 5, which is going to give me 2 times 1 is 2 plus 5 is going to give me 7, right? And then I'm going to move on and I'm going to do 2 times 4, which is going to give me 8, plus 7 is going to be 17. Sorry, 2 times 4 plus 7 is going to give me 15. Or sorry, 2 times 4 plus 5 is what I'm doing. 13. Right? I'm just taking the 4 value from here, plugging it into my mapping notation and putting it down. Right? And then last but not least, I'm actually not gonna do the next one because if I did 2 times 9, I already know it's 18. I already know when I add 5 to it, it's just gonna go off my graph because my graph only goes up to 23. So, or sorry, 20, so I'm just gonna ignore it. But if I had to put that point in, it would be 23. Moving forward, I'm gonna go ahead and plug in all my y values. So if I have y over here, it's going to be -3 times 0 plus 4, which is going to give me 4. Then I have -3 times 1 plus 4, which is going to give me 1. Then I have -3 times 2, which is going to give me -6 plus 4. I have -2, right? And the last one is going to be for 3 times -3, which is going to give me -9, plus 4 is going to be -5. And again, I can't even plot this on the graph because I don't have a 23. It's just there so you can see how we would do it if we had more than 1 or 2 points. Then I'm just going to go ahead and plot these in. Right, so I'm going to go ahead and plot in the values that I have onto my graph. I personally like to do it in the same color that I did it in. So my original base function I did in black, so my base function was in black. And I'm just going to go ahead and plot in my points for my new function over here. Okay, so I have 5 across, up 4. All right, so like this. And then I have 7 and 1. Right, so I'm just taking the points from my new point graph and putting it in. And then I have 13 and -2. And then last but not least, I have 23 and -5, which I'm not going to put in here, but it would be somewhere off this graph over here. And then I'm just going to go ahead and sketch that curve in, right? And that is what my new function is going to look like. If I wanted to do a quick check, does it make sense? Yes. It looks like it's vertically stretched. It looks like it's horizontally stretched. It's getting wider in both directions. I can tell that it's moved up by 4, and I can tell that it's moved right by 5. So this function to me right now looks right, and I can just kind of do a self-reflection in that sense. But basically what this does is it saves you the trouble of having to draw multiple graphs, and it kind of helps you streamline how you're going to graph your points. So I hope this was helpful. That is just a little bit on how to use mapping notation. If this was a helpful video, please subscribe. Thank you. See you again.